Hello, assalamu alaikum. Good morning, everyone. Today, I am going to simulate an fuel cell, PEM fuel cell, proton exchange membrane fuel cell. Basically, for the very beginning of our simulation, I am going to uh, explain what is a fuel cell actually. If we Here we can see this is an fuel cell. Basically, a fuel cell is an direct energy conversion device by which we can convert uh, chemical energy directly into electrical energy. Here we can see a schematic of a PEM fuel cell or proton exchange membrane fuel cell. Here we can see an electrolyte membrane is here. By this electrolyte membrane only hydrogen ion can be passed, but no other ion or electron can be passed by this. So here you can see this portion is the anode portion and this portion is the cathodic portion. So here very close to the membrane we see a catalyst layer and then a microporous layer or MPL and then a gas diffusion layer or electrode. Then here we can see an anode collector. This is an hydrogen. Uh, we pass hydrogen gas by this, and here we can here the ER is given. In the ER, basically the oxygen is provided. So when the in this hydrogen, when the ER is given to this, the when the hydrogen pass through this, hydrogen ion pass through this, the hydrogen ion and oxygen reacts with each other and they form water. This water can be bring out from this cell, and when hydrogen gas removes electron and converts into hydrogen ion, then the electron pass through this load, and by this mechanism the load is electrolyzed, or we can get electricity from this. So this is the basic mechanism of a fuel cell. We will not discuss the fuel cell um, here. So this is the very basics of a PEM fuel cell. We will not describe elaborately the PEM fuel cell here. We will just give you the very uh, finite. আবার। So this is the very basics of a PEM fuel cell. We will not describely elaborate the working mechanism of PEM fuel cell. We will only here to know the basics of PEM fuel cell. Then we move on to here. We can see this is the actual visualization of a PEM fuel cell. This is the one cell basically. Here different types of cell in there, but today we will simulate different kinds of fuel cell uh, like this, but the shape is quite different from this. So then basically we take the data from this paper, this research paper, we use this. So now we move on to the our ANSYS simulation software. To simulate fuel cell in ANSYS, we need to open fluid flow fluent. Here we drag the fluid flow fluent. This and after dragging this, we have to first save up this projects. So we here we go save as, and then we create a folder. We have to create a folder here because for multiple for different project we need to create different folder for our convenience. So here we named it for video. Okay, for video I copied this and we'll go to the folder and then name it as it is. Okay, then save. It takes time some time. Okay. After saving, we open the geometry. Here we right click the geometry folder, geometry, and we open the design modeler geometry, new design modeler geometry. You can do in other other module as well, but for this we are using design modeler. This is our design modeler. So here we first go to the create of file option, then attach external geometry file. Sorry, I have to I have forget to mention that I have already created a PEM fuel cell design in SolidWorks. So I will give that SolidWorks file in description. Check it out for the for this file. Here this is our file. We just select this file and then open. So here we can see the file is loaded, but we have to generate the file. Here we click the generate. Then if we have to give some times to generate this file. Basically, this is our PEM fuel cell. Here we can see if we want to see what we have been learned in our previous in our theory, that this is the flow, the or hydrogen flow. This is the air flow, and this is the PEM fuel cell. So here we can see the all the components are given here according to name. Um, so we don't give any much time in this. So just we have to do just import this file in design modeler, so we don't need to do any work in this module. So I will close this. Then we move on to the meshing. We double click the mesh and it takes some time to open the meshing. So here we can see the PEM fuel cell and in meshing. So at first we have mesh. We need to mesh this fuel cell. Then we keep it very simple. Just we mesh. We change the element size from here. We give it 0.5 element size, only 0.5, and you can do another meshing in this. You can fine tune this mesh as you need, but to keep it simple we have only reduce the element size, then generate. Okay, we can see the our meshing is completed. Then we have to named selection. We have to naming our all the parameters or all the surfaces and bodies here. So at first we have to we will name our bodies. Here we can see this is our current collector. So here at first we choose our body collector. Sorry, we choose body. Then we select this and in from keyboard or right click. If we right click this here, we can find out that there is a create named selection. So when I click create named selection, here we can we give the name. This is our current collector, or simply we named it as current anode. And this is our flow channel. We named it same in from keyboard. This is our channel anode, and we if we closely see, this is our GDL or gas diffusion layer. GDL anode, and here we see the a very little component. This is this is our catalyst layer or CL. We named it as catalyst anode, and this is our fuel cell, or sorry, this is our membrane, and this is catalyst cathode, and this is GDL cathode, and this is channel cathode, and this is current cathode. Okay, our body naming is done. Then we will move on to the phase naming. This phase is named as tab. So this is basically tab anode, and this is our tab cathode. And this surface we name, this is our inlet of oxygen, inlet of hydrogen or anode. So we named it that inlet anode, and this is our outlet of cathode. So in the opposite side we choose, this is outlet of anode, this is the inlet of cathode. Okay, and finally another thing we have to name, that is porous jump layer. So to create porous jump layer naming, so we select this, and here we right click and hide all other bodies. Then we see that there is a, if we create in this named selection, so here you can see that there is a surface. So we select this, and again in from keyboard, this is our porous jump anode. Okay, then right click and show all bodies. Then we need to do same for cathode, hide all other bodies and select this, and in porous jump cathode. Okay, our named selection done. So then right click and show all bodies. Then we move on to the meshing and update. Okay, we see that our mesh translation to Fluent is successful. Then we go to the setup. So you can do right click and edit, or double click to the setup. It takes some time to open the Fluent module. When we when the Fluent launcher is open, we can see there is such options. We will select the double precision, and here we can use multiple processor. Here I use 8. You have to use according to your processor configuration. So then start. Okay, here is our fuel cell. So now we have to activate activate the uh, fuel cell module. So here we go to the console. We write these commands slash define slash models add-on module. Here we can see different add-on modules. From this we will select PEM fuel cell module, which is in 9 number. So here we enter 9. So after enabling this, here we can see a PEM fuel cell module or model is opened. So for the very beginning, we enable the energy equation. Then we go to the species, double click to this species, and species transport we select. Then okay. Then we go to the PEM fuel cell, enable this. So here are different types of fuel cell parameter we have to change according to our paper. But for this, I am not consider. I will. But for this, I will not consider the value of this. Only the required value which is must necessary for this, we will have to change those. Otherwise, all other parameters will be um, default value. So here we only choose the electrical system setup. In this electrical system setup, we see three setup in boundary condition panel, specify total voltage, specify total current. In the paper, the total current was mentioned. So here we select the specify total current, and this is in this I choose that the total current voltage current is 7.2 ampere. Then we move on to the parameters. In this parameter, we have to change different settings. So for this time, I will leave as it is. Then we move on to the anode. The current collector, we have to choose the current collector. Here we can see the current anode. So this is our anode and current collector. So we choose our anode current anode. This is our current anode, and we have to uh, give the mark on update cell zones, and we have to select solid materials from. So here we have to choose collector default. Then we go to the flow channel. So we have to select channel anode. Then porous electrode. Porous electrode is the GDL, so gas diffusion layer. So we choose GDL anode, and here we use diff layer. Then TPB layer or catalyst. Here we select the catalyst anode, and from here catalyst default. So also we leave as it is because we will not change the value, but you have to change according to your needs. And microporous layer, here we are not using any microporous layer, so we will not select anything. Then for in electrolyte we choose membrane, and here we choose the electrolyte. In the cathode we select the same as anode, but for this we select the cathode. So here current cathode, and here the collector, flow channel, channel cathode, porous, GDL cathode, and from there diff layer. TPB catalyst cathode, and this is catalyst. And in the microporous layer we will not select anything. Then electrical tab, we will select tab anode, and from here we here we will select tab cathode. Then advance in contact resistivity. We'll select the porous jump anode and porous jump cathode. We will give the value 1 e minus 5 ohm meter square. We'll select this and paste it. Then we go to the report. No need to change anything in customize UDFs. Report, create monitors and enable calculator. Then apply. This is a warning. This shows this is probably not what you want, because we don't we don't select any porous layer, so we can ignore it, and then apply and then okay. Okay, then we go to the materials. We see that there is a solid materials and some mixture, so we don't need to change anything of this, so we'll leave as it is. Then we go to the cell zone condition. So here in the cell zone condition, here we can see that uh, everything is fluid, but we need to change the membrane into solid. So then the source, and then we no need to change anything. We will leave as it is, but just apply. Okay, then our current anode and current cathode, this also be solid. We will select this solid. So this is our solid. Okay, and current cathode, this also be solid. Apply and close, and others will be fluid as it is. So you have to check it out. Okay, then we will go to the boundary condition. In our boundary condition, at first the we have to input the inlet anode. So here we select from type, we select mass flow inlet. So in the paper it suggests, it mentioned that the mass flow rate is 1.798 minus 6, and the thermal temperature is 353.15 Kelvin, and species is, for anode only hydrogen will be there. Hydrogen, this will be 0.4941, and oxygen will be 0.5059, and UDS will be the same as it is. Then apply and close. We go to the inlet cathode. Sorry, we have to select the mass flow inlet. We will select, we will give the value 4.473 minus 5. Then the thermal temperature is 353.15, and the species is, here only the oxygen and water molecule, so 0.21, and H2O is 0.067, and then we apply, close, and okay, you then in tab anode we click and edit. Then we go to the temperature and give the temperature is 353.15, and apply, close. Also for Tap cathode is go to temperature and 353.15 close. Then we have to go, our boundary condition is ready. Then we go to the methods. We don't need to change anything. We will leave as it is. Then we go to the controls. In control, we have to reduce the under relaxation factor. We the density we will give this as 0.2. We will give almost everything is 0.2. You can change this value according to your simulation, but for my for this simulation, this value is okay. So body forces 0.2, momentum we will give 0.5, h2 0.2, everything I will give 0.2. But water content I will give 0.02, and the liquid saturation channel I will give 0.02. Okay. Then we go to initialization. We just simply initialize. We simply initialize. Okay. Then our initialization is done. Then we go to the run calculation. So we double click the run calculation. Here we give 100 number of iteration, then start calculation. Okay. I'll be back after calculation when the calcula. I'll be back when the calculation is done. Here you can see our calculation is completed. So then I will just calculate the cell voltage from the report definition. I right click on this and then compute. In the cell voltage I right click and then compute. Then we can see the cell voltage is 0.607. So this is the simulation of our PEM fuel cell. So that's all. Thank you.